Hello, today we'll be looking at some of the special triangles that you'll be using in your trigonometry courses. So the way that we're going to construct our 30 and 60 degree special right triangles come from this equilateral triangle that I've drawn with each side being equal to 2. I know that in an equilateral triangle every angle is going to be 60 since the angles of a triangle have to add up to 180. So I'll draw a 60 here to show that. What I'm going to do next is I'm going to cut directly down the middle of this top part to make a perpendicular bisector, meaning that I'm cutting this top angle in half, and it's going to be a right angle to the edge I'm connecting to. So now this right triangle on the left has an angle of 90, an angle of 60, meaning that this top angle has to be 30 in order to reach 180 degrees. Now that I've cut this bottom leg of my triangle in half, since it started out as 2, this side right here is going to be of length 1. So all that's left is to find the height, and from there, since I have a right triangle, I can use the Pythagorean theorem. Since I know the hypotenuse is 2, and I have one of the legs being 1, I can say that 1 squared plus, we'll call it y squared equals 2 squared. So I get 1 plus y squared equals 4. So I get y squared equals 3. So I know that this missing length for the height of this triangle is going to be the square root of 3. So say that y equals the square root of 3. So now that I've created this triangle, we're going to introduce some trigonometry. I just can say that sine of 30 degrees is going to be, let's see, the opposite of 30 is 1, and the hypotenuse is 2, so the sine of 30 is 1/2. I can say the cosine of 30 is going to be the adjacent, which is the square root of 3, over the hypotenuse, which is 2. And finally we have tangent of 30 degrees, which is going to be opposite over adjacent, so it's going to be 1 over square root of 3. And if we rationalize this denominator, it's going to be square root of 3 over 3. Alright, let's start using 60 degrees for these trig functions. I can say that sine of 60 degrees, again, sine is opposite over hypotenuse, so now the opposite of 60 is square root of 3, and the hypotenuse is 2. So the sine of 60 is square root of 3 over 2. Similar to before, the cosine of 60 is adjacent over hypotenuse, so the adjacent of 60 is 1, and the hypotenuse is 2, so the cosine of 60 is 1/2. Finally, we have tangent of 60, which is opposite over adjacent, so the opposite of 60 is square root of 3, and the adjacent is 1. So the tangent of 60 is square root of 3 over 1. Now that we've covered the 30 and 60 degree special triangles, let's talk about how to find the 45 degree one. We're going to start off by drawing a square where every side is going to be equal to 1. Since this is a square, I know that there is a right angle right here, and on all sides as well. So what we're going to do now is we're going to cut this square in a diagonal. So let's get a new color, and let's cut a diagonal down this way. Now that I've cut this right angle in half, I know that this new angle here is 45, and this one also is 45. And then similar to before, since I have 2 of the legs, but I don't know this missing value right here, we can use the Pythagorean theorem to find out what the hypotenuse will be. So I can say that 1 squared plus 1 squared equals, let's call it z squared. So this is going to be 2 equals z squared. So the hypotenuse is going to be the square root of 2. Square root of 2. So now that I have the hypotenuse, we have the triangle. I have a 45, 45, 90 triangle with the sides 1, 1, square root of 2. So now we can use some trigonometry and say that sine of 45 is going to be, let's see, opposite of 45 is 1, and my hypotenuse is square root of 2, so this is 1 over square root of 2, which if we rationalize the denominator will be square root of 2 over 2. So now finding cosine of 45 is actually going to be the same thing, because cosine is adjacent over hypotenuse. Well, the adjacent of 45 is also 1, and the hypotenuse stays the same, so this is also 1 over square root of 2, or square root of 2 over 2. Finally, to find the tangent, we have opposite over adjacent. Opposite of 45 is 1, and the adjacent of 45 is also 1. So therefore, the tangent of 45 is 1 over 1, or simply 1.